Hello and welcome back for another special VMK in the game development series. This VMK will show you how to implement the third-person camera that we've been working so hard in the previous VMK to get prepared for. To have a third-person camera working, we need to have a 3D model of the player that we're going to be rendering in front of the camera view. To create this 3D model, what I've done is I've gone inside of TrueSpace, and inside there's a library of different kinds of 3D models. What I did is I just grabbed one of a human-looking character, and I've placed it here under, under Resources, Models. There is a file here called player.cob. I loaded it inside of the file viewer program and converted it to a VMK file, which is what you see here. I needed to do this because there's some transformations and scaling that I needed to do so that the model is the appropriate size and shape inside of our game. Now notice one other thing. The model itself is centered so that the 0, point is located roughly where the eyes are located inside of this model. You need to do this because once we import this model of this character inside of our game, we're going to be looking through his eyes. So we're going to be looking through the 0, point inside of this model. And wherever we place the 0, point, that's where the camera is going to be located. So be aware that once you select your model, place 0, wherever his center point is. Let's get rid of the grid for now and take a closer look at this model. It's just a standard model. He's holding a little spike in his hand that later on you can go and animate his arm to swing that spike if you like, or whatever you like. So that's our model that we're going to be using. Let's close that off, and there's the file itself. Oh, I forgot to point out one other thing. Inside of the scene graph here, notice that there's a bunch of different nodes for creating the model, but the root node is called player.scn. So that's what we're going to be using anytime we want to transform, rotate, scale him. We need to access the transform that's called player.scn. Okay, so now let's go into our code. We need to load this 3D model into memory, and we'll do that whenever we initialize our scene. Actually, not whenever we initialize, but rather when we call load level data. At the top here, we've defined our player class to have a specific position. We load in some lights, and over here we load in our testing.lvl file. This is that flat scene with the barrels and boxes on the screen. Before we start implementing any new code that has to do with this third-person camera view, make sure that your VMK loader is working. You can test this by typing in load VMK file and then specify a VMK file that you want to load. What I've done here is underneath the resources models directory, I've placed this chair.vmk that came with the file viewer VMK. So if you haven't done the file viewer VMK yet, it will explain to you how to create this VMK loader, and it also gives you some files that you can add into your project, which you can see here under the object lib. If we scroll down here, you should have a VMK file.cpp and VMK file.h already in your project. There were some changes into the Caligari poly-h as well as into the geometry compiled classes, so you'll need to make those changes, and all those changes are shown inside of the file viewer VMK that's also on this DVD. So if you haven't done that one yet, go ahead and do that VMK first and then come back to finish off this last VMK. I'm assuming that this should be up and running on your computer. If you just type this in, compile your code, and give it a run, what you should see is something like this where you have your scene, and in your scene there's just this chair to represent that you were able to load in a VMK file. Alright, your VMK file loader is working. Now what we're going to do is use a VMK file to represent our player. We're using the load VMK file function to load the player.vmk file. What we're going to do is we're going to look for this player.vmk file within our scene graph using find node. Once this function finds player.scn, remember this was the transform node that we named as the root for our 3D model. we're going to then save the pointer to this node transform inside of m_p player transform. This is going to be a member within our scene class. If he's valid, then we're going to call a function called setRotationAxis on the player transform to indicate that we are only going to be rotating the player's 3D model about the y-axis. If you want to do animations and things like that, you're going to handle that separately inside of the update function. So with this new code added, let's compile, and you'll see that there's a bunch of error messages that pop up for the missing functions that we don't have. But knowing which ones we need to implement is helpful. Okay, this is not declared, so let's go into our scene.h and declare him inside of the member variables, right down here. It's just a node transform pointer, which I've named player transform. The other error that we get here is find node is not defined. And find node is going to be a function that we can call upon any node within our scene graph. So we'll go into our node class, and in here we're going to add a find node function. Oh, we already have it in here. It's just capitalization that's the problem. Well, let's change that then. And let's try compiling this. Okay, we're missing setRotationAxis. Let's go take a look inside of node transform to see whether that's also a capitalization problem. No, it doesn't look like it. We don't have a function called setRotationAxis. Let's go into node transform and add this new function. Currently, what we have is we have this vector 3 here that represents the rotation axis, but he's public, which means that anyone who wants to use this member variable, he can have direct access to it. What we want to do is take him out of here and place him inside of the private section, like so. By doing this, we can guarantee that anytime a user wants to change the rotation axis from the outside of this class, we will maintain that this axis is unit length. And this is important because of any rotations that we do are going to scale depending on the length of this rotation axis. And we don't want that to change length on us, so we're going to force it to always be unit length. In here, I'm just going to type in node transform as well. So by adding that, we now no longer have access to the rotation axis. So to give back access to the user, we're going to create two functions. Let's put them up here. We have setRotationAxis, where we pass in a vector 3. We have setRotationAxis if we pass in a x, y, and z value, as well as if we pass in a floating point array. And to get the rotation axis, we call it getRotationAxis. Now let's go into our node transform.cpp file, and just at the bottom here, we're going to implement those new functions. Here's setRotationAxis with the vector 3 as the parameter. We're going to take this value, we're going to normalize it, and then we're going to save it inside of our member variable. The return value is a Boolean, so we're going to use the isZero function call to determine whether he's 0 or not. If we have a setRotationAxis called by passing in an x, y, and z, then we're going to create a vector 3 and then call this setRotationAxis function. Same thing down here. If we have an array, then we're going to take those array components, create a vector 3, and then call this setRotationAxis. And no matter what, we're always calling this one set of code, and I do this so that we don't have duplicate code down here that does exactly the same thing. Later on, if we want to change the functionality of this, we'll only have to change it to one spot rather than 3. The last function here, getRotationAxis, just returns our member variable that has the rotation axis in place. So let's save him, and where were we? I think we were inside of scene.cpp. Yeah, here. So we should now be able to compile him. However, if there's any code laying around that tried to access the rotation axis directly, we'll now have to use these new function calls that we just created. So that's what we see here. Inside of parse line for scene, we're trying to set the rotation axis directly inside of this parser. We need to change this code now so that we use the set rotation axis function call, and we have a choice whichever one we want to use. Because we are defining a vector 3 here, we might as well just use this guy here. Just comment that out and do the following. And compile him and fix some more. Here, same sort of thing. We need to call set rotation axis. Again over here. He's inside of a for loop, so we're going to pull him out. And as a matter of fact, you can see I already had the code written here. P transform set rotation axis, and then we're passing in 3 floating point numbers that represent the rotation axis. Next one is this one here. Again, same thing. We're just going to delete that line of code and replace it with this one here. Let's try compiling him. Okay, let's try building. Normalize is not a member. Maybe capitalization? Yeah. Okay, that compiled. If we go and run our program, we should be able to see our 3D model. But notice that he's located right there at the very bottom of the screen, and his head is only popping up above the ground. Remember, 0, 0 was getting rendered sort of in the middle of his head there. We are currently not updating his position as we're moving around on the screen. To do that, we need to add a new function. So let's just close all this stuff off. And back inside of scene.cpp, we want to update the player. And remember, our player is now being controlled by that new new member variable that we created, m_p player transform. He's responsible for keeping track of our player character within our game. If we go inside of the update function, here's where we're updating the player's position, updating the camera. So after we update the camera, we can update the player's transform as well. To do this, all we need to do is check to make sure we have a player transform. If we do, then we're going to take the camera and call getThirdPersonLocation. This function is going to be responsible for taking a look at the camera parameters and saving the translate value as well as the rotation angle inside of the player's transform. So this function is returning 2 values, translate and angle. After updating mPlayer transform, whenever we go and render everything down here, the player will then be updated correctly on the screen. So now let's go inside of our camera class and implement this new function. camera.h. Right here we're adding getThirdPersonLocation, passing in a vector 3 as an address and a floating point number as an address. Because we're passing these as addresses, we can return values to these parameters to be used outside of the function. And we need to open up our CPP file. Let's just implement it right above set. To start off, we're only going to update the position. And then once I show you how that works, then we're going to go in and update the angle. So for now, the angle, we're always going to set it equal to 0. The position of the model that we want to render on the screen, we can get from the looking center and the eye position values, which are part of the camera. The X and Z coordinates are going to be located wherever we're looking at. The eye position is how high we are inside of the scene, so the sort of vertical height, and we're going to take that Y component and save it as the Y component inside of the position vector here that we're going to pass out of this function. So let's save this, try compiling him, and let's build our program. Let's see how this one change influences our game. we can now see that right in front of us we have the player character. And as we're moving around, he's moving around with us. And of course, we haven't implemented any animation, so his legs aren't moving. He's just skating around on this grassy scene right now. And no matter what we do, he's always facing us because we're not updating his rotation. Now here's something interesting. Let me go inside here. Notice what happens when I turn my head using the mouse. As soon as I turn my head, I am turning my scene. You can see the scene is changing the rotation, but my character is still facing in the exact same direction. If you look exactly what's happening, he's always pointing. Let me do it this way. Notice that he's facing so that his back is to the barrels, which are behind him. If I'm turning this way and I look at him sort of from the side, his back is still to the barrels. If I turn this way, his back is always to the barrels. Because I'm not rotating him, I'm just rotating the scene. So you can see, I can look around him, but I cannot make him rotate around. We haven't implemented that just yet. Now, in a third-person game, you may want to give the ability to sort of look around your own player rather than getting stuck with only seeing the back of his head. But that's, neither here nor there. It's something you can implement yourself. Right now, we haven't linked the rotation of the camera to the rotation of the player. That's why he's always facing us. To make that one change, all we need to do is update the angle of the player whenever we're inside of here getting the third-person location. The little bit of math that's involved is shown right here. We need to get the angle of the camera with respect to the global frame. To do that, we can get the looking center vector and the eye position vector. Taking the difference between these will give us the overall direction vector that we're pointing in, and we have the x component of that vector and the z component. Then to get the angle, we can just take the arctan of x and z, and this will give us the angle in radians that we need to rotate our player character about. The result of this is always radians, so we're going to convert this to be in degrees because our scene graph uses an angle defined in degrees. Now let's save this and rerun our program. Now notice that the player character's back of the head is facing the camera, and no matter which way we turn, his back of the head is always towards the camera. There's no way now that we can see his face or his eyes or anything on the front of him because he will always maintain his back towards the camera. We're almost done with the third-person camera, but there's one other thing we need to change. Notice that when I'm walking around, he's always in front of me, but notice how he's moving. Let's say I place him over here between these two boxes. If I place him between two boxes and then I move towards the left, or sorry, not move, but turn my head towards the left, I'm actually sliding him through the box. Same thing if I go towards the right. He's going through the box. That's not the correct motion you should be seeing. When you're turning your head left and right now we're pivoting about the location where the camera is, which is back from the player character. However, we don't want this to happen. We want the player character to be the center point that we're pivoting about. Let's go into PaintShop Pro to see exactly what this means. In the first-person camera view, which is currently what we're using, we have the position of ourselves, which is the camera's position, and we have the position that we're looking at. When we're rotating our view, or our head, you could say, then we're changing the position of our look-at point with respect to the position of the camera. So this is the guy that's moving. However, in a third-person camera view, you want this scenario. You want the look-at point to be fixed, and you want the position of the camera to be rotating around. So when I turn my head 30 degrees to the left, in a first-person camera, I'm moving the look-at point 30 degrees to the left. However, in a third-person camera view, if I'm turning my head 30 degrees to the left, that actually means I'm turning my home position 30 degrees to the right, like so. So we have to make this distinction mathematically so that the rotations behave correctly. To make this change, we just need to make two slight changes inside of our player class. So let's open that up, and it's inside of move. Currently, when we're looking left or looking right, this is the code that we're using. And notice that we're changing the look at center location with respect to the position. Well, now we have to flip this around so that we're changing the look at position with respect to the center. Again, let's reference this. Here, we're first person camera, we're changing our look at position with respect to the position. Third person, we're changing our look at position with respect to the look at location. To make this change, all we need to do is add a minus sign in front of both of these. So two minuses will be a plus, so this becomes a plus. Adding a minus sign here, we'll add a minus sign. Down here, we're adding a minus sign, so adding a minus sign. And the other thing we need to change is flip these around. Instead of position being here, we're going to put it over here. And instead of having position here, we're going to put the look at center there, like so. And we have to do the same thing for the right as well. So with that slight change in code, let's just recompile this and now test it out. Now notice that when I'm moving the player around, let's put him between those two boxes again. Notice that as I'm spinning now left and right, he's not moving through those boxes. Instead, he's staying put, and the camera is rolling around the player as I'm spinning him around. Before, he was sliding and the camera position was fixed. Now, he is fixed and the camera position is sliding around him. So there we go. We've now implemented a fully functional third-person camera view. Next thing you can go ahead and add is animations to the character, which I've already sort of shown you how to do that. If you go inside of the scene class, inside of update here, after you do all these calculations and before you render, in here you should go in, start animating the pieces of the 3D model that you want to have animate.